Alright, so section 13.5 is kind of pulling together everything we've talked about, solving equations using trig, and there's just one thing I want to point out. This sheet on how to solve trig equations. So there are 6 different kinds, and we'll go through each, several types of each. First thing to decide is which type of equation, because there's different strategies for each one. So you can have a double angle or half angle identities. Those are easy to recognize. You can have a GCF or a trinomial to factor, and I'll show you how to find those two. A Pythagorean identity, or something where you have to square both sides. So let's just go down the list. Here I can recognize we have several double angle identities. So that's going to be this strategy right here, strategy number 1. And this kind of shows you how to do it, but I'll show you right now. So that's the first thing, is just decide which type of equation we're being asked to solve. And you can see both 37 and 38 have double angles in them, so that's the one we're going to use. Okay, this is also important. Solve each equation for any angle from 0 to 360. That means usually we're going to have 2 to 4 solutions for a lot of these, and we have to check. Sometimes you get extraneous solutions too. So let's start by combining the like terms here. So we'll subtract this sine squared right here, and we'll subtract this sine squared, and then we'll have negative cos squared theta plus sine squared 2 theta. In most of these equations we want to only be dealing with one single trig function, not with 2. So if you look at this identity right here, sine of 2 theta equals this. So let's plug this in here. So sine of 2 theta is this. It's 2 sine cosine. And this is saying take that and square it. So that's what we'll do. So we'll have negative cos squared plus, if we square 2 we get 4, and if we square sine squared and cosine squared is what we get right there. Okay. Let me just rewrite this so it's a little bit neater. We have 4 sine squared cosine squared minus cosine squared. Okay, now let's go back to our strategies for a sec, because sometimes multiple strategies factor in. So we took care of the double angle. There's no more double angles. If you look at strategy 3, it says factoring the GCF. And the GCF is, you might see it, but there is a GCF right here, the greatest common factor. It's this, it's cosine squared. So, by the way, this whole side is equal to 0, so I should have been putting equals 0 this whole time. But this is still equal to 0. So now let's factor out a cosine squared. See what's left behind. If we divide this thing by cosine squared, we'd be left with 4 sine squared. If we divide this thing by cosine squared, we'd be left with minus 1. So now the question is, how do we make this equation equal 0? Well, there's 2 ways that could happen. Cosine squared of theta could equal 0, or 4 sine squared of theta minus 1 could equal 0. So let's start with this side. We'll add 1 to both sides, so we get 4 sine squared is equal to 1. We'll divide both sides by 4. So sine squared is equal to 1/4. We'll square root this and put a plus or minus in front. So we're going to get sine is equal to positive or negative, and the square root of 1/4 is 1/2. So positive or negative 1/2. So where does that happen? Where does sine equal 1/2? Hopefully you remember the sines and cosines for these angles right here. If not, I'll put them up here so we can have them. So the sine of 30 is 1/2. This one is root 2/2. This is root 3/2. And these go the opposite, root 3/2, root 2/2, and 1/2. So the sine of 30 degrees is 1/2. But there's actually all 4 places on this coordinate. So 1/2, remember, sine is the y coordinate. Here's a y coordinate of 1/2. That means this y coordinate over here, the unit circle, is also 1/2. So that means this angle right here is going to be also have a sine of 1/2. That's this yellow one, and that's going to be 180 minus that 30, which would be 150. And then also these 2 angles down here, these 2 reference angles of 30 right here, are also going to have signs not of 1/2, but they'll have signs of negative 1/2. So this orange angle right here is going to be 180 plus 30, which is 210. And this, running out of colors here, this purple angle right here is going to be almost 360 except for that last 30. So 360 minus 30 is 330. Okay, so you're going to have 4 answers from this. You have 30, which is here, 150, 210, and 330. So 30, 150, 210, and 330. Those are all the different ways that we can make sines of either positive or negative 1/2. So we have 4 solutions coming from that, and then we'll have, looks like at least 1, maybe 2 solutions from here. So cosine squared, we'll take the square root of both sides. We get cosine is equal to positive or negative 0, just 0. So let's look at the unit circle again. Cosine refers to the x-coordinate. So on the unit circle, where is the x-coordinate equal to 0? It's equal to 0 here, and it's equal to 0 here. So that one is 90 degrees, and this one is 270. So we have 6 solutions actually, and that's the maximum that you can usually get. So we have 90, 270, 30, 150, 210, and 330. So let's double check. We have 6 solutions, and we do 90, 270, 30, 150, 210, 330. Those are the 6 we had, and obviously you can check by plugging those back in. There's really only one that you have to check for, though, and it's not this one. I'll show you later on when you would have to check. Alright, so 38, we again have a double angle, and with sine we don't have a choice. We know that sine is going to be this one right here. Cosine we have a choice, and I'll show you later on how to make that choice. Okay, let's put everything on one side so we have stuff in standard form. And this is probably going to involve another greatest common factor. You'll start to see the patterns with these pretty quickly. So 2 cos minus 4 cos is minus 2 cos. And yes, they do have a common factor. It looks like they have a 2 cosine in common. There's the 2 and there's the cosine. So let me give some more space here so that we don't get kind of lost with that other work. So I'm just going to rewrite this. 0 equals 2 sine cosine. Let's pull out a 2 cosine right here. And when you pull out a 2 cosine from this one, you're just left with sine. When you pull out a 2 cosine from this one, you're left with minus 1. So now we'll make 2 equations. I don't think we're going to get 6 solutions this time like we did before. 2 cosine equals 0. That's how this could be 0. And sine minus 1 equals 0. Let's solve this one first. If we add 1 to both sides, we get sine is equal to 1. Where does that happen on the unit circle? Sine is the y-coordinate. Well, there's only one place where the y-coordinate equals 1. It's right there at 90 degrees. So this solution would be theta equals 90. And then right here, we'll divide this by 2. We'll get cosine is equal to 0. Where does that happen? Well, I'll use the same unit circle. Cosine is the x-coordinate, and the x-coordinate equals 0 here. And it also equals here. So we already covered 90. I'll just write it again, but we don't really need to. The other place is down here at 270 degrees. So there's only 2 solutions for that, 90 and 270, and that's it. Okay. So again, we talked about those different strategies. These are still double angle problems, and you can see why they're double angles. Double angle means there's a 2 theta there. So that's how we know. Okay, but we might use some of those other strategies. So here's the problem. We have a cos 2 theta. How do we decide which of these 3 formulas to use? With sine 2 theta, we don't have that problem. How do we decide with cosine? And the way we decide is you look at what else is in the equation. There's a cosine right there. So I want to keep everything in one trig function. I want to keep everything as cosines, and that means using this middle identity right here. Okay, because that only has cosines in it. So 2 cos squared minus 1, we have that plus 2, and we have that plus 3 cosine, and this is equal to 0. So this is going to be 2 cosine squared. I'm going to put the plus 3, so it's supposed to be a plus, I'm going to put the plus 3 right here, and then negative 1 plus 2 is positive 1. Okay, so now what do? We look at our sheet again, strategies, and it's not going to be a GCF, this is going to be strategy 4, factoring a trinomial. And if this doesn't look like a trinomial to you, here's what you can kind of imagine here. Take cosine and replace it with a letter, like call that x. So this, if cosine means x, then 3 cosine would be 3x, and 2 cos squared would be 2x squared. So this now looks like a trinomial, and we can factor this right here. So numbers that multiply to 1, they would both have to be positive 1. Only things that multiply to 2 would be 2 times 1. And so that's how that factors right here. This thing factors out, foils out to that right there. Alright, so let's replace the x. So x, remember, is standing for cosine. We don't have to do that, by the way. I just did that so you can see how it looks like a trinomial. So 2x is the same as 2 cosine. And this is still equal to 0. Okay, so we have 2 equations here that we have to solve for by setting equal to 0. So let's do that. So this thing right here could equal 0, or this thing right here could equal 0. Let's start with the right one, it's a little bit easier. So subtract 1, cos is negative 1. Here's our unit circle right here. Cosine is the x coordinate, and if you look here for the x coordinate equaling 0, it equals 0 here at 90, and it also equals 0 here at 270. So that means our two solutions, sorry, I misspoke there. We're not looking for 0, we're looking for negative 1, so that's not right. The only place that it equals negative 1 is, let me redraw this for a sec. The only place that the x coordinate equals negative 1 is right here at 180 degrees. So there's our one solution from there, theta equals 180. Let's solve the other side right now. So if we subtract 1 from here, we get 2 cosine is equal to negative 1. Divide by 2, that means cosine is negative 1/2. And that's one of those special angles, the 30, 45, 60 angles. The one that has a cosine of 1/2 turns out to be 60 degrees. Sine of 30 is 1/2, cosine of 60 is 1/2. So it's 60 degrees, but it's 60 degrees where cosine is negative, because this is a negative 1/2. So we need 60 degrees, but in the two quadrants where cosine is negative. And those two quadrants are this one and this one. So we need 60-degree reference angles in these two quadrants. So that means this angle right here is almost to 180 except for that last 60. So 180 minus 60 is 120. So there's our first solution from this side. And then we use a different color here. This angle right here all the way to past 180 plus that extra 60, that would be 240 degrees. So theta is also 240. So 120, 240, and 180. And again, we could always check those. You could take cosine of 120, you could plug that in a calculator and you'll get negative 1/2. Or you could plug in 240, you'll get negative 1/2. So you have a calculator on this part, so you should be able to check it that way. So 120, 180, and 240. Let's check to see if we did that right. 120, 180, 240. There it is. Okay, this one right here, number 40. We again have a double angle. Let's start by combining these like terms here. That's always a good first step. So plus 3 sine 2 theta plus 3 sine 2 theta. So now this is 0 equals sine theta. Negative 4 plus positive 3 is negative 1. Okay, now we need to use the double angle, and sine only has a single double angle identity. It's this one. It's 2 sine cosine. So this is not a trinomial. This is a greatest common factor. You can see they both have a sine in common. So we'll pull out a sine. We box this off. So we'll pull out sine. And what happens if you divide this one by sine? You get 1. Divide this one by sine, you get 2 cosine. All right. So let's. Sorry, this is getting messier than intended here. So we'll get rid of all this stuff. Okay, and then I'm just going to rewrite it over here. So 0 equals sine times this. Okay, how do we make this 0? There's two ways. We can make the sine equal to 0, or we can make the 1 minus 2 cosine equal to 0. Let's start with the left side, because that's easier. Here's the unit circle. Sine is the y coordinate. So where on the unit circle does the y coordinate equal 0? It equals 0 here and here. That's 0 degrees, and that is 180 degrees. So our two solutions from here are 0 and 180. There's two solutions. Let's find the other side now. So this side right here, let's subtract 1 from both sides. So we'll get negative 2 cosine equals negative 1, and we divide by negative 2. Cosine is equal to 1/2, and we did that on the other problem. We said that that's at 60 degrees. And it's also equal to, remember, it's all students take calculus. Where's the other quadrant where cosine is positive? It's down here. So whatever 60 degrees is down there. And let's think about it. We're going all the way around here until we get right here. That's 360 except for that last 60. The 360 minus 60 is 300. And the other solution was 60 degrees. So we have four solutions. We have 0, 180, 300, and 60. So let's double check that. 0, 180, 60, and 300, and that works. Alright, still some more double angle identities, but we'll still be able to see these strategies in use. So let's do this one. Okay, now again, how do we decide? Cosine has 3 double angles. How do we decide which one to use? I look at the rest of the equation. The rest of the equation has signs in it, so I'm going to use the identity that only has signs, which is 1 minus 2 sine squared. We have to be wary of this negative right here. So 1 minus 2 sine squared, again I decided because the other side had a sine squared and I just want to keep only one trig equation happening, or one trig value. So we'll distribute the negative, so negative 1 plus 2 sine squared equals negative 2 plus 3 sine squared. Let's put everything on the same side, so we'll subtract this 2 sine squared, and we will also add back this 1. So we're going to get 0 is equal to negative 2 plus 1 is negative 1, and we'll put that right here. And 3 sine squared minus 2 sine squared is 1 sine squared. So now we have this, so let's look at our strategies. There's no GCF, but there is a factoring that we can do. We can use the factoring. It's not really a trinomial, we can still factor it. And you might recognize that. That is actually a difference of squares. Because this is a square, it's sine times sine, and that's a square also. And so part of the challenge with these problems is just recognizing what you're dealing with. So how did I get sine squared? I did sine times sine. How did I get the 1? I did 1 times 1, and then to make a difference of squares, 1 has to be plus, and 1 has to be minus. So let's set each of these equal to 0, because we are trying to solve. And then we'll subtract 1 right here, and we'll get sine equals negative 1. We'll add 1 right here, and we'll get sine equals 1. Where does that happen? Here's the unit circle. Sine is the y-coordinate. So the y-coordinate is equal to 1 right here at 90 degrees. So that's one solution. And the y-coordinate is equal to negative 1 down here at 270 degrees. So that's another solution. So sine is equal to 90, and sine is equal to 270. And the reason they have those in radians, we could leave it as 90 and 270 just because they started by telling you the answer in radians. But 90 degrees in radians is pi over 2, and 270 in radians is 3 pi over 2. But our answer is right. We can just leave it in degrees. There's nothing wrong with that. Alright, 42 is the last one for this video. Cosine 2 theta. So remember, we have a choice with cosine. There's three possibilities. How do we decide? Well, notice that the rest of the equation has only cosines in it, so let's pick the one that only has cosines. That's this one right here. So let me box this off. So this one we're going to change to 2 cos squared minus 1. We have that minus 2 there, and we have that plus 2 cos squared, and this whole thing is equal to 0. 2 cos squared plus another 2 cos squared would be 4 cos squared, and then negative 1 minus 2 is negative 3. So let's add 3 to both sides, and we'll get 4 cos squared is equal to 3. We'll divide by 4. And so we're going to get cosine squared equals 3 over 4. We'll solve for cosine by square rooting and putting a plus or minus. So cosine equals plus or minus root 3 over 2. Okay, so which angle has a cosine of root 3 over 2? And it turns out to be theta is equal to 30 degrees. That means, here's the thing, we need a plus and a minus root 3 over 2. So here's our unit circle. Where is cosine positive? Cosine is positive here and here. We also need this minus. Where is it negative? It's negative here and here. So we should have 4 solutions. 2 places where it's positive root 3 over 2, 2 places where it's negative root 3 over 2. So that means all of these reference angles here are all going to be 30 degrees, because that's the one that has a cosine of radical 3 over 2. So we already know one of them is 30. Okay, let's kind of draw different pictures here. So this angle right here, that's going to be 180 except for that last 30, which would be 150. So that's our second solution, is 150. That has a cosine of negative radical 3 over 2. And you could check that. You can plug that in the calculator and check pretty easily. This third quadrant angle is this one. So that's 180 plus an extra 30, which is 210. Cosine of 210 is negative radical 3 over 2. And then finally, this last one is this whole purple angle, almost 360 except for that last 30. So 360 minus that last 30 would be 330 degrees. That's our 4 solutions. So let's double check. 30, 150, 210, and 330. And 5 or 6 is 30. So that one works. This one, it converts to 150. That one converts to 210, and that one converts to 330, so it does work. And that is most of the equations that you would see using double angles. In the next video, we'll start with number 43. That's actually still a couple more double angles, but we'll see some of the other strategies as well.